Hi everyone, thank you for joining this session. My name is Amit Purohit and I will be presenting this session on Jumpstart Your Low Power IoT Sensors Application Development. So let's get started. As we all know that Internet of Things is rapidly emerging as the next generation of smart and connected world. It is estimated that by 2025, there will be approximately 75 billion end devices connected to the IoT. And in order to support that pace at which IoT devices and applications are evolving, it is imperative to have a quick and easy enablement support available as well. NXP has a rich history of supplying motion sensors into automotive, industrial, and medical IoT markets. And we at NXP believe that easy enablement is of utmost importance to reduce evaluation, development, and time to market. And this is the area where we want to differentiate against our competitors. In this session, you will learn about NXP's sensor development ecosystem and how it is making easier for our customers to migrate through each phase of their product life cycle while they choose NXP sensors for their design. I'm highlighting here the session's agenda. So in this session, we are going to learn about sensor proliferation, where we will look at how sensing technologies are transforming use cases of all applications that touch our daily life. We'll learn about the key motion sensor features driving low power IoT applications. We'll discuss these considerations from our customers while choosing motion sensors for these kind of applications. And then we'll learn how we are taking those customer considerations to design our next generation motion sensors, and we will introduce you with our next generation accelerometers. After that, we'll learn more about sensor development ecosystem and the key benefits offered by each component of that ecosystem. That will be followed by a description on the system solutions that we have developed based using our motion sensors. And of course, these are powered by our developer enablement ecosystem. Finally, we will summarize what we learned today in this session, followed by Q&A. So as I mentioned that NXP's next generation sensors, we feature a strong balance of intelligent embedded features, ultra low power consumption, and customizable platform software to enable smarter and more differentiated applications. And this is all possible based on the customer feedback and how customer evaluating our sensors. We also offer sensor development ecosystem, which provides unmatched enablement and development flexibility with software and tools to simplify customers' evaluation, development, and design using our NXP sensors. In this training, we'll cover some of those design considerations on choosing low power sensors for low power IoT applications. We'll introduce you with our new products, low G accelerometers, followed by more details on the sensor development ecosystem offering from NXP. So let's talk about sensors proliferation. We know that sensors are everywhere. Probably you don't realize it, but we are surrounded by many invisible sensors, making our life easier. And we can't even imagine a world without these tiny invisible sensors that enable all the devices that make our modern connected world run so smoothly. So as I mentioned in this slide, that sensor proliferation is all over, right from, I'm trying to mention here some of these domains where we already see a lot of sensor applications, like in auto non-safety applications, key fob navigation, in smart industry 4.0, factory automation, smart city like smart retail, smart access, temper theft detection, in health applications. It's emerging very quickly, like telehealth, healthcare, wearables, and in smart home. We are all aware it's a very good area where we have a lot of home automation, smart appliances, and security. From the NXP side, we are committed to provide developers ecosystem enabling NXP sensors across all these applications that not only helping customers to quickly jumpstart their development, but also it is helping accelerate mass market adoption of our sensors and tools. Our main aim is to offer our customers great out-of-box experience and improve their ease of use with a common set of enablement software and tools for all NXP sensors, irrespective of the application, the end application. Now let's talk about some of the sensor features based on our customer feedbacks that they think are driving low power IoT applications. When we talk about motion sensors, the first thing that comes into our mind is parametric features like what is the performance of the motion sensor? What is the resolution of motion sensor? What is the sensitivity, offset noise? What is the full scale range supported by the motion sensor, and what is the response time? Also, we can talk about what is the output data rate supported. Now, these are the main motion sensor features that comes to our mind. But do we have something beyond that? If we are in a domain where we are competing on an application space where we, let's say, are meeting the parametric performance, then what all other key features can drive our design win? I'm trying to list down some of them here, and those are ultra low power consumption. So whether your sensor provides low power features, the configurable low power modes, some of the features like auto wake sleep and interrupt mode, we'll talk more on that. Embedded functions. So embedded functions are making sensors intelligent by providing some of those functionality available as a configurable sensor registers. You need not to write complex code or algorithm to make it work to detect some of the very basic motion gestures. And of course, even if you have all these cool features, it may or may not be possible for your customers to use it properly. And that's why hardware and software enablement is very important to provide ease of use, ease of evaluation of our sensor parts, so that there's a good out-of-box experience from our customer. I'm listing down some of the other features as well, like self-diagnostics. Now, self-diagnostics enable quick diagnostics in the field. It helps quickly check device health. And why it is important, because this kind of feature, if the sensor has, then this can be run in the production to access device health. Now your sensor has been integrated into a overall solution, and you can quickly check at any point how's the device health, and you can segregate that out, that sensor is doing fine, the overall solution. And of course, the ease of integration, how easy it is to integrate your sensor solution into the overall solution or product from our customer. In this session, we will be learning more on these highlighted customer considerations while choosing motion sensors for industrial and medical IoT applications. So let's learn more about these key sensor features. Ultra low power, as I said, it's in my opinion is the most important feature while customer is choosing a motion sensor. They look for features like what all configurable power modes available in the sensor and how easy it is to migrate between those power modes. They also look for, and the customer do ask us, what is the power consumption in the low power mode? It can be nanoamps, so that without any issue, the sensor can still detect some of the motion gestures, and it can provide an ultra low power wake up feature. There are some other few features which we have seen that customers shown more interest. It's auto wake sleep feature. So when we talk about ultra low power consumption for low power wake up, we should also look at how autonomously sensor can detect that there is no motion and automatically go to the lowest power mode without any user intervention. This actually makes this whole low power wake up feature autonomous. You configure the sensor once And you know that it can go to the ultra low power consumption. And when it doesn't detect any motion, it can autonomously go to the sleep mode again. And of course, we provide interrupt mode. So it's very easier for user to just configure once before starting their application and wait for the interrupt whenever there's a motion and the sensor autonomously go back to sleep. Some of the key takeaways for this specific motion sensor feature is customers are asking for these features so that to check whether they're fully configurable, whether the power modes are fully configurable. It's easier to migrate between different power modes, and it provides a completely autonomous solution. There's no need to get the raw data. You are just configuring based on some motion gestures, and the sensor works autonomously. The current consumption in idle state, when it goes to a sleep mode autonomously, it should be, let's say, in nanoamps in low power wake up mode. And what is the lowest ODR output data rate at which still sensor can detect any motion? Some of the other features are auto wake sleep, interrupt mode, and hardware FIFO. All of our sensors support hardware FIFO. So even if you are configured for interrupt mode, whether your solution needs to have you interrupted on every event, do you need that? Or you can have a hardware FIFO defined so that you don't need to wake up your system on every interrupt, but this can be configurable as well. This provides further flexibility for your use cases. And we have seen that just by adding these ultra low power motion sensors in your design has the ability to reduce more than 3x to 4x overall power consumption. I would also encourage you to look for another sensors NXP Connect session that talks about motion sensors for power management of connected IoT devices, where we are talking more about this low power feature, and we are discussing some of the real use cases where motion sensor is helping increasing the battery life of the overall solution by 3x to 4x. Now let's talk about the other feature, embedded functions. So embedded functions, when I mention embedded functions, these are some of the inherent functions or blocks available as part of the sensor itself. And it's easily configurable, and you just need to configure it. You need not to write any complex algorithm or code. So it's very low code, low memory kind of feature, and it helps you detect most of the inertial events like a shake detection, motion or no motion detection, a twist, a tap or double tap, a free fall detection, or a change in orientation. And how is it possible? As I said, these embedded functions can be a block within your sensor, and it provides programmable thresholds and timers. I'm mentioning SDCD function here, and we'll talk more on it when I will be introducing our next generation accelerometers. But think of this function as a highly configurable digital window comparator for easy and efficient implementation of low power motion detection. And it also provides programmable FIFO, as I mentioned. So even in these detections, for example, for tap, you would like to configure it for multiple taps, and then you should declare that somebody is tapping on my door, right? So you can use the FIFO to detect each tap event, and based on that, you can declare after having sufficient taps, you can declare that this is a knock on the door, right? Similarly, shake, you can detect a shake event, but then you would like to configure your inhaler to have at least 4 shakes to make sure that the medicine is now ready to be used. And you can, of course, use these as a FIFO or multiple events together to make such a decision. So what are the key takeaways from this feature that we discussed just now? As I mentioned that for most of the application, you don't need raw data. You don't need a lot of data to be transmitted. You just need some motion event detection. Can it be done by sensor itself so that you don't need to do it using post-processing on the raw data? And of course, it reduces your bandwidth because now you are just working on an event. event is there or not. It reduces the latency and computational requirements of the system. And that's where we see the benefits of adding a motion sensor that helps in saving the battery life. It also ensures low power IoT operations and interrupt mode. All these events, as I mentioned in previous slide, you can configure in interrupt mode, and it can interrupt based on whatever inertial event detection you have configured for. It requires no complex algorithm. It's a low code, low memory. So it doesn't constrain anything. You can run it on a very low memory, low CPU constrained devices as well. So these are some of the key takeaways from this embedded functions feature. And we mentioned about the self-diagnostics. Now, this is a feature that provides verification of mechanical and electrical integrity of the accelerometer. Right? It can be run in production system to access device health. It is unaffected by device orientation or motion. So in summary, this helps a quick diagnostics in the field. You integrate your sensor in the overall solution, and it's deployed in the field. Now, how to know that how a sensor is behaving? You can quickly move that into the self-test mode, and it provides you self-test results. These are some of the very cool features that help for the maintenance of your sensors when it is deployed in the field. So some of the key takeaways are, of course, this feature enables quick diagnostics in the field and help quickly check device health. You can do a periodic check to make sure that the sensor health is good. And it's very easy. The migration from self-test to the normal mode, it's easily configurable, and it can be monitored, or let's say programmed to have this self-test mode run quite frequently. So all these are very easy to perform. And last but not the least, as I mentioned, that you can have all these cool features that can give you an edge over your competitor, but if they are not able to use it, then it's of no use. If they are finding it difficult to use those features, they have to go through data sheet and all the collaterals. It takes them days and weeks to actually be able to start using those features. Then it's a very bad user experience. And that's where the development ecosystem or the collaterals that we provide for enabling our sensor solutions is of great help. It helps in improving ease of use and quick evaluation of our parts and accelerate end user development. And we proudly would like to mention here that we take pride in our development ecosystem, that we are not only helping in improving ease of use or quick evaluation of our sensor in the early phase, but our development ecosystem is also helping them in their development and prototyping and design phase. We have those software and tools available that actually covers their whole production life cycle. And it of course improves their out-of-box experience, which is very important in our mind. So these are our key takeaways for this feature that we think is very important driving factor, and it giving us edge over our competition. As I mentioned, that most of our competition can provide you some of the evaluation tools, but they cannot provide tools which can help you in your overall all production life cycle phases. We are providing tools for ease of evaluation, development, and design prototyping. There's no need to start from scratch. We have hundreds of reference out-of-box examples that we provide to configure sensors in different modes, how to use different blocks of the sensors. We provide demo GUIs for evaluation purpose, which provides you direct access to each and every registered bitmap. And also we provide reference algorithms. We are going to talk more about our sensor development ecosystem in this session, and you will get more awareness on these tools. And we have seen that over the time, while we are working on and improving this ecosystem, we have gained customers' confidence, not only in our products, but the way we are delivering the out-of-box experience for them. So now let's talk about our next generation 3-axis accelerometers. And these are designed by considering the key features that we have discussed in the previous section. The FXLS8964 and 8967 family of 3-axis accelerometers are designed for key fob and general non-safety automotive applications that require ultra-low power wake-up on motion. Some of the key features are listed on this slide. So I'll start with the compatibility replacement. We already have a product in the market, FXLS8962, and 8964 will be replacing this part, and it's fully pin and software compatible. So it will be really easy migration for our existing customers to move from 8962 to 8964. It's ultra low power. It takes less than 1 microamps in low power wake up mode and still can detect motion gestures, still within 0.7 hertz to 6.25 hertz ODR. It has a SDCD block. We discussed this part as part of our previous slide. So SDCD block is a way to provide efficient and flexible inertial event detection function with the ability to detect inertial events like free fall detection or tap detection or any kind of change in motion no motion detection. So it's a really configurable feature that allows our customers to configure based on their use case. The next important feature that we also discussed in previous slide is self-test diagnostic. So these all new products, they support self-test, and basically this feature provides verification of the mechanical and electrical integrity of the accelerometer. And how this is helpful, this actually enables quick diagnostics in the field. So when you deploy this sensor and there's something going bad, then you can quickly self-test the sensor and you can decide based on that analysis. It supports ±2 to ±16G full scale range. It's a 12-bit resolution sensor. It supports both I2C and SPI digital interfaces. And it comes in 2x2 DFN package. It's a 10-pin package. And it is AEC-Q 100 auto and industrial qualified, supporting -40 to 105 degrees Celsius. The target applications for 8964 is a very specific application, which is a key fob motion detection, whereas the FXLS8967 is targeted for general auto non-safety applications like telematics, T-box, car alarm, electrified doors. The samples for these products are available now, and the production release is targeted for mid of 2022. The next product is FXLS8974, which is targeted for IoT industrial medical application requiring ultra low power wake up on motion. Again, this is pin and software compatible with 8964 and 67 parts with a very minor ASIC change. There's a very minor digital only change that impacts functionality of SDCD block only. So it doesn't impact the overall functionality. It's pin and software compatible with just a change in HOMI, product revision, as well as a very small base ASIC change. The key features remain the same. The ultra low power can go to 600 nanoamps, ultra low power wake up detection. The target applications are of course different. So we are targeting here medical variables, asset tracking, cameras customers to detect tilt, smart meters, connected home, equipment monitoring, and surveillance and security. For this product as well, the samples are available now, and we are targeting the production release along with 6.4 and 6.7 in mid of 2022. Moving on, let's learn more about the sensor development ecosystem now. As I have clearly mentioned that NXP is fully focused to provide easy enablement across all portfolios of motion sensors and creating differentiating development ecosystem that gives us edge over our competitors. We offer a development ecosystem which provides unmatched enablement and development flexibility with software and tools to simplify customers' evaluation, development, and design using our NXP sensors. Our sensor development ecosystem comprises of 3 components. We provide sensor evaluation boards along with the embedded software framework, which help them program the board. And we also provide some demo firmwares as well. And we have a sensor evaluation and visualization tool, which user can directly use as a plug and play software. They get access to all the sensor features, register set, and also they can develop their own GUIs. And when we started developing and enhancing this ecosystem, we had following key benefits that we want to offer to our end customers in mind. We wanted to shorten their development cycle. We want to accelerate end user evaluation, prototyping, and development phase while they are using or considering NXP sensor platforms. Increase of use, we wanted to increase ease of use and ease of adoption with our sensor demo kits and reference enablement collaterals. And of course, the most important thing is quality user experience. What is the out-of-box experience when customers come to us and they ask for part evaluation, right? We provide them multiple out-of-box sensor reference and algorithm examples. The way we provide to them, it's very easy to use, and that increases the customer user experience. Now let's go and learn about these components of sensor development ecosystem one by one. First, let's talk about the sensor eval boards. We are offering eval boards. We have multiple offerings in our eval boards. We provide a demo kit, which is a combination of a shield and an MCU, which provides a complete solution for out-of-box sensor demonstration and evaluation. And these are available on our NXP Sensors website. User can visit them and they can request it, and they get total out-of-box experience using our demo kit. We also provide dummy sensor shield board, which can be used as an extension add-on board for any Arduino compatible NXP MCUs or Arduino development MCU boards. It comes with some of the test pins as well that help in your prototyping and development phase. We also provide a breakout board, which is a small form factor board. It's ideal for custom prototyping or custom design. Once users go through the evaluation phase and they start developing their own custom boards, then the breakout boards are very helpful in those scenarios. And we also started offering custom kits. So by custom kit, what we mean is that we can provide shield board from Sensors Group, and you can use this as to attach as an add-on board, extension board for any MCU board which has Arduino compatibility headers. We have written our software in such a way that you can use these as a Lego blocks. You can connect a shield board to a MCU board and just configure those Arduino pin mux definitions, and the examples will run seamlessly. So that's how we support or we are extending our ecosystem to not only supported standard demo kits, but also for custom kit that user can use. I'm showing here an example of upcoming Gemini eval kit. We have the prototype boards available for FXLS896 Gemini eval kit, and we are also providing evaluation GUI and software tools. It's available upon request. The picture is showing a first prototype version of the board. It's available, and we are also working towards mass market readiness for Gemini. We'll be providing full evaluation development software solution for Gemini, along with easy to use documentations like user guide, application notes. We are planning to launch, as I mentioned, that the production launch for Gemini FXLS8974CF is targeted for mid-2022. And we are planning to launch this eval kit along with all the software collaterals and documentation on the NXP web before product launch in 2022. Also, I would like to mention here that we are expanding our ecosystem outside of NXP using third-party boards. We are working with a company named Microelectronica, which is NXP's gold partner. And we are using the MicroE click boards microbus add-on standard for our next generation accelerometer as well. Microbus, by the way, is the fastest growing add-on board standard. And Most of the next generation NXP's MCUs as well, like i.MX RT or LPC families, they're already adopting the the microbus standard. On the right side below, you can see a picture of an existing MCU, LPC55S16EVK, which provides both Arduino headers as well as the microbus headers on the MCU. And we are planning to have uh, Arduino support through our NXP ecosystem and microbus support through the third-party boards, which we are working with Microelectronica. We are building FXLS89xXAF click boards with Microelectronica, and it's under development right now. We are planning to launch in Q1 of 2022. And this partnership project will help expand our sensor ecosystem. Now let's talk about the other component of our ecosystem, which is embedded software framework. IoT Sensing SDK or ICE SDK is the main sensor embedded software framework that we provide that covers all of our motion sensors. And it provides a robust set of sensor drivers and algorithms along with example applications that user can get started with using our NXP sensors. And we have also integrated our sensors SDK, IoT Sensing SDK, into a broader ecosystem called MCU Expresso SDK. Let me talk briefly about MCU Expresso SDK if you're not aware of it. MCU Expresso SDK is a unified way of providing MCU SDKs for Cortex-M based microcontrollers that we have. We have a Kinetis families of MCUs, LPC families, and i.MX RT crossover platforms now. All of them are supported through MCU Expresso SDK ecosystem, and we have integrated Sensors SDK into the MCU Expresso SDK as a middleware component. So this provides us a very good end user experience with the overall tools and collaterals available with MCU Expresso and their web-based delivery system for releasing the SDK. And this helps us integrate with them and keep on adding new features with their new MCU NPIs coming up. The key benefits that we offer through ICE SDK is, of course, it is open source. ICE SDK sources are released under BSD3 clause, open source, which allow user not only to use it, modify it, but they can also redistribute the sources for their own purpose as long as they keep the NXP copyright information intact. It's easily portable. As you can see that the ICE SDK low-level interfaces are SIMSYS driver compliant. Now, SIMSYS is a Cortex-M standard interfaces provided by ARM. And if your low-level interfaces are compliant with SIMSYS definitions, then it's easier to port across different NXP's ARM Cortex-based MCUs. So this provides us high portability. Since we integrated with MCU Expresso SDK and we are providing production grade quality there, we provide lots of hundreds of out-of-box examples. We have these are MISRA 4 compliant, and we have a fully tested solution for our customers. So it's a production grade quality. And of course, the main benefit that we get out of this integration into MCU Expresso SDK is the tools integration. We are able to use all the MCU Expresso tools and cross compilation tool chains, and of course, different development environment as well. So this further enhances our quality and out-of-box experience of our IoT Sensing SDK. In this slide, I'm talking more about the architecture details of the ICE SDK. So ICE SDK is following a layer cake architecture. We have tried to make the layers modular and separable so that user can accordingly choose. As you can see in the purple color, these are all the blocks of ICE SDK. And we have a low-level interface which are SIMSYS compliant, and they directly access the underlying MCU peripheral drivers. And then we provide a a modular wrapper on top of low-level interface called functional interface, where we provide further ease of use for our customers to directly focus on a specific customers. We provide very basic 4 APIs in functional interfaces: how to initialize a sensor, how to configure a sensor, how to read the data from sensor, and how to deinitialize the sensor. So they need not to worry about the further details of how to access the peripheral drivers using low-level interface, and function interface provide them further flexibility and ease of use. As I mentioned earlier, we also provide some of the algorithm demonstrations like sensor fusion and pedometer. These are using sensor data that we extract out of the sensor, and they run some demonstration algorithm to show how multiple sensor data can be fused together to make a more meaningful information out of the system. And of course, you can do some other computation to make it work for pedometer applications as well. And of course, as I mentioned, we provide hundreds of examples, out-of-box examples, using most of them using bare metal and some of them using FreeRTOS applications. In terms of deliverables, what we provide in ICE SDK, we provide a detailed sensor register map definition so that user has access to each and every bit fields of the sensor registers. We provide sensor drivers with modular interfaces, low-level interface, and functional interface. And as I mentioned, in our layer cake architecture, they are modular and separable. If user don't want to use functional interface, they can just use low-level interface. Or if they want to use function interface as well, they can use that as well. We provide algorithm libraries and out-of-box examples that runs on our sensor eval kits. And all the ICE SDK sources are BSD3 open source. I talked about sensor fusion offering from ICE SDK. I would like to talk briefly about it as well now. So as I mentioned that we offer a reference sensor fusion algorithm library as part of ICE SDK. Now, what this algorithm is, the sensor fusion provides a process by which data from several different sensors are fused together to computing something more meaningful that cannot be determined by a single sensor data alone. This example shows that how you can fuse multiple sensor data together to compute the orientation of a device in 3D dimension more accurately. And it tells you that, and it describes you that if you use accelerometer only data, your 3D orientation is not that smooth. When you combine it with the magnetometer data, you see that it's improving. But when you combine this with the gyroscope data as well, the total line axis data, you'll observe that you can compute the orientation of the device in 3D space more accurately. It also provides advanced functions for computation of linear acceleration, gyro offset, magnetic interference based on the output from NXP inertial and magnetic sensors. Again, this sensor fusion library sources are released with ICE SDK under OpenSDA, open source BSD3 clause marking. So it's available, and these can be, as I mentioned, that BSD3 allows end user to not only use it, modify it, but also redistribute for their own purpose. They just need to keep the NXP copyright in the sources intact. And also we provide, as you can see on the right side, we provide a Windows GUI sensor fusion toolbox, which help you analyze the sensor fusion output in real time. We are also working on a software called Sensor Component Library. Now, software component library is the collection of platform agnostic sensor components. So we also receive feedback from some of our customers that they would like to have a platform independent sensor components like sensor drivers, sensor algorithms, some applications, which can be, easily portable or easily used for non-NXP MCUs as well. So we started working on component library, and which is a collection of platform agnostic sensor components. We provide code snippets, sensor drivers, algorithms, and these components are designed with modular and flexible interfaces to allow platform abstraction. Yeah, the underlying SDK can be MC Expresso, Kinetis SDK, Embed, ARM embed on any open source. The abstraction provided by component library allows us with minimal changes needed, and then you can have these components working for your underlying device as well. The sensor component interfaces to low-level driver implementation is kept generic enough so that it can be adapted for underlying host MCU SDK implementations. And you can see some of the key benefits offered by component library. As I mentioned, it's platform agnostic. So you can choose any MCU and SDK with minimal change in the abstraction, and you will be able to use for any MCU and SDK. It's open source again, BSD3 clause, and we provide some of the reference examples so that it allows you to learn how you can use the component library abstraction for low-level drivers. And now let's talk about the last component of our ecosystem, which is sensor evaluation software visualization tool. We have a tool called FreeMaster Sensor Tool, which we are using as not only for evaluation and visualization, but also we are offering that as a application development software tool for NXP sensors. It uses FreeMaster framework internally. If you are not aware of FreeMaster, then let me describe briefly about FreeMaster first. So FreeMaster has been, we are offering from NXP from quite some time now, and FreeMaster is initially developed as a real-time debug monitor tool. It allows user to program some of your key variables and registers that you would like to monitor in real time. And you can easily monitor them using the FreeMaster. But over the time, this tool has been evolving for as a data visualization tool as well for application development, ideal for industrial IoT and automotive applications. Now we have adopted this tool and we have tried to create templates that can be easily used for any sensor that we offer. So it comprises of FreeMaster sensor drivers that comes as part of IS SDK and MC Expresso. And on the host side, it comes with a easy to use and easy to change HTML based application where you can easily create any control page. And you define some of your variables, you get direct access on the host side, read and write access. So there's no need of creating any command response kind of application. All the parameters, all the register set, all the control variables that you expose using FreeMaster drivers on the device side are directly accessible as read and write variables on the host side. And you can directly access them. You can create some of these using the open source HTML widgets. You can create drop-down menus. You can create some buttons and charts. And on the top left side, you can see that as part of this tool, we also provide a detailed read and write access to all of the sensor registers in real time. Here you can read all sensor registers. You can modify the bit fields of those sensor registers and see the impact in real time. And also FreeMaster provides a very cool way to provide to program using Node-RED extension. As you can see in the middle of this slide, the Node-RED is an open source software, and FreeMaster include that extension and provide FreeMaster modules into the Node-RED. So user can drag and drop some of those FreeMaster blocks and create their own state machines and control the board or monitor some of these registers or control variables. We are offering this tool. So as I said, we have out-of-box evaluation GUIs available for end users, but it doesn't stop them to enhance this for their own purpose. They can create their own GUI. Okay, in this slide, I'm mentioning the key benefits that we offer through FreeMaster Sensor Tool. We provide a real-time sensor register control. This enables modification of memory variables registers in real time. And this helped actually to enable us to implement a sensor register web page for our out-of-box demonstration. which provides a detailed bitwise access for our sensor control in real time for read and write registers. You can actually toggle those bits and apply a register write in real time. You need not to go through the state machine of putting the sensor in the idle mode, then applying the sensor write, and then putting back in the active mode. So it is transparent to the end user. We also provide a sensor real-time output monitoring. So user can define multiple memory variables getting updated at their individual sampling rates. And it's very easier to monitor them on the host side GUI. It's just a matter of clicking it's a right click to add an oscilloscope or a graph view, and you can add multiple outputs in the single graph as well, or in the single scope as well. And as I mentioned that as part of our out-of-box demonstration GUI using FreeMaster Sensor Tool, we are providing sensor register page. It provides a detailed register map for the sensor and allows real-time read and write of the bit fields, and you can check the sensor behavior in real time. As part of our out-of-box demo, we provide a quick demo plug and play that user can quickly check using our sensor eval kits. And running this demo, it provides most of the basic embedded features, access to the sensor registers, and some of the configurations that they can do while they're evaluating our sensor parts. And the most important thing, the most important key benefit that we offer is integration with the standard mature tools from NXP. On the device side, we are using FreeMaster drivers to integrate into IS SDK and deliver through MCU Expresso SDK. You get out-of-box examples. You just need to build them and program your board, sensor eval kits, and you have the FreeMaster drivers implemented there. And on the host side, we have integration with FreeMaster 3.x, which provides flexibility to extend, create your own GUI. Now, both of these tools are NXP's mature tools. Many of our existing customers already are using these tools. They're familiar with this tool. This further enhances our out-of-box experience for our when they use sensor toolbox ecosystem. So we talked about all these tools, sensor ecosystem tools. And in this slide, I'm highlighting again that how it is helping to migrate our customers not only in the evaluation phase, but other phases like development, prototyping, design phase to complete their whole development life cycle. Most of our competitors just support in evaluation phase. But as you can see, we have some other collaterals available so that we can support in their whole development life cycle. During the evaluation phase, we have sensor eval kits to support from the hardware side. We have out-of-box embedded software examples and firmwares that they can use directly. And we have out-of-box demonstration GUIs for evaluation purpose. But when customers move to the next phases of their development, like they were doing prototyping and development for their product, we have a lot more to offer to them. As I mentioned, we have sensor shield board and breakout boards that they can use for their chosen MCU. And we provide ICE SDK sources to them, out-of-box examples to them, and flexibility for them to modify it for their own purpose. We also help our customers to provide some custom examples or custom features added. And of course, during their prototyping and development phase, they can visualize those output using a very basic serial terminal using UART, or they can they can choose to update FreeMaster Sensor Tool for their own purpose to verify their product design. Now, moving on, let's talk about the sensor system solutions enabled by our motion sensors. These are some of the reference design which we have worked with our different business lines or business units within NXP to create a more complete solution that we offer to our customers. In this slide, I'm covering some of the sensor reference designs for IoT segments, industrial and medical IoT segments. And the whole idea is that how we can integrate multiple technologies from NXP together to create a more a ready to use and meaningful solution for our end customers, demonstrating an actual real use case. So the first two reference designs, NTEX sensor board and NTEX sensor button, is based out of our collaboration with the personal health group within NXP, who's owning the NFC or NTEC technology. And the idea was to add motion sensor FXLS896X to not only create like smart logistics asset tracking kind of application, but also factory automation, machine monitoring, and predictive maintenance kind of application. So in the smart logistics or asset tracking kind of application, as you can see on the left-hand side, uh, we have added a MEMS accelerometer, low power wake up accelerometer for not only detecting various motion events like a shock, a tilt, free fall, these kind of events when your asset is shipped. So your motion sensor in this kind of device attached to your shipment or your asset can track all the motion events happen. It basically tells you how the package was handled during the flight. And once it reaches to the destination, it using the NFC and tag, just tapping on the asset, it gives you all the log information, and you know that if any high value asset or perishable goods were shipped, how those were handled, and whether you want to discard them based on those events. This basically helps improve the user satisfaction. On the other design, which is targeted for machine monitoring or predictive maintenance, you can see that the coin cell size device can be attached to your industrial 4.0 machineries or your home machines, like your dishwasher, your washing machine. Now, what it does is once you attach this, and you can program the board to detect the normal behavior of those machineries. So it monitors them, it programs them, and then when it detects any anomaly or any change in the vibration of those machineries or devices, it can alert you that this is not a normal behavior. So this can help you in the predictive maintenance of those machineries and device, and it can help reduce the cost of the manufacturing if you happen to halt your whole production system because of any failure. So this can help doing the predictive analysis or maintenance. Recently, we have collaborated with the ultra wideband team, and they are targeting some IoT applications using the ultra wideband tag reference design. And the main use case initially targeted for ultra wideband tag kind of reference design was indoor localization. The idea is to have this again a very small form factor coin cell sized device attached to your key fobs or your home devices, whether you are in the smart home environment or in smart industry environment. You can attach to any of your devices, and you can localize them with a high accuracy using ultra wideband and BLE technologies. Now, in the first version of this tag design, motion sensor was not integrated. And later, while discussing with us, they identified that there can be new set of use cases that can be defined as part of this tag Rev2 if we have motion sensors added to this design. So motion sensor when got added, it's not only creating new set of use cases like temper theft detection for high value assets or how high value devices at your home to which you can attach these kinds of tags. It can also creating like smart safe workplace kind of use cases and helping in reducing the power consumption of the overall solution by 3x to 4x. As you can see that all of the reference design we're talking here are operated by batteries, right? So in all of them, motion sensor is not only helping in getting motion events and getting some smart alerts, but it is helping to improve the battery life of such remote devices or battery operated devices by 3x to 4x. And the last one we have is Sigfox Asset Tracker. This is based on the Sigfox and GPS technology to not only track the asset, uh, what is happening with the asset, but also track the location, the exact location of the asset while it's shipped. So again, it is operated by two AAA batteries, And initially, the initial version was supporting max 25 to 30 days of battery backup. Now think of a situation where you have shipped this asset and it's lying in the inventory or their warehouse for a longer time, right? You still want to you still want to locate the location and what is happening with the asset. But if the battery dies, you cannot do it. So motion sensor, when it's got added, it's not only helping in shock monitoring, free fall, tilt detections, but also providing a power optimization based on just to enable the Sigfox or reduce the Sigfox RxTX time to minimum based on when the motion is detected or or some anomaly has been detected. So that's how you can see that motion sensor is getting more and more integrated in different technologies so that we provide a complete solution to our customers. And all these designs are enabled by our software development ecosystem for sensors. While we start the discussions around these reference design, we first target our ecosystem hardwares and software collaterals to implement those features, and then we get into the exact reference design. So basically, it helps create the whole good ecosystem. All right, we have reached to the summary slide of this session now, and I would like to summarize some of the key points we discussed in this session. So we discussed that NXP has been supplying motion sensors not only in automotive, but also in industrial medical IoT markets. And we are more focused now to provide a complete hardware and software solutions and not just providing a part to our customers. And based on some of the customer feedback, we are providing easy enablement across all portfolios on motion sensors, creating differentiating development ecosystem that gives us edge over competitors. I discussed that we are offering unmatched enablement and development flexibility with our software and tools, not only to simplify customer evaluation, but also help them in their development and design phases when they're using NXP sensors. We are continuously improving our ecosystem collaterals, and the main aim in our mind is to improve ease of use for our customers when they choose NXP sensors and accelerate their evaluation, development, prototyping phases using our sensor solutions. I hope this session was useful for you and it gave you a good awareness on our next generation sensors portfolio and sensor development tools and software. I hope this session also helped you get comfortable with our offering in sensors, hardware and tools, and it will motivate you to learn more about our ecosystem by visiting our NXP web pages for Sensor Toolbox ecosystem. In this next slide, I'm providing a quick references or some of the links where you can directly go and learn more about our tools, our eval boards, and some of the software ecosystem that we have. And this will give you more information there. Also, don't forget to visit our virtual showroom and learn how NXP technology advancing and automating our future. For more details, please visit showroom.nxp.com. Thank you for joining the class. If you have any additional questions, please reach out to your NXP representative or ask your question in the featured community below this video. Thank you.